How's it going, guys? Hope you got to California safe. This is going to be day one of the little geometry YouTube videos that I'm going to be uploading that will help you get done with that geometry packet so you can get to the much more fun stuff about having to go on your field lesson and you won't have to be in your hotel room doing your packet all day. So I'm going to be doing this with respect to your time and my time. So we're going to treat this like a normal class. We're going to start with our do now. If you look on the board behind me, this is the first page of your packet. And right here we have our first problem. So what I'm gonna ask you to do is you're gonna pause the video in just a bit. You're gonna take about 2 or 3 minutes to try this on your own. But let's recall what we remember about whenever we have a triangle that is overlapping a circle. So if we notice here, we have a point of tangency at L. And I remember that whenever we have a radius and a tangent line, we always have a right angle in there. So, something to help you out, you can pause the video now and give it a try. All right, and we're gonna bring it back. So what we're gonna start with is we're gonna do our do now, and right after that, then we're gonna transition into our notes just like we would in a normal class. So first thing I'm gonna do is identify that right here in our circle, we have a right triangle. Now, that tells me that I can do a lot of things. If I'm looking for ML, and ML would be right here, then I need to find the whole side of JL first. So I'm gonna use the Pythagorean theorem. I'm gonna write that down. Pythagorean theorem. We got an A squared plus a B squared equals a C squared. Now, I see that 16 is opposite of the right angle, so I know that 16 has to be my C. So I'm gonna set up 9.6 as A squared, then I'll set up JL as X squared, and that is gonna equal my 16 squared. So I'm gonna do my squares and simplify this. This is going to give me a 92.2 plus X squared equals 256. Subtract 92.2 from both sides. And this is going to give me an X squared equals 163.8. You're gonna be looking at my back a lot, so just be ready for that. So now I'm gonna take my X squared equals 163.8. Have to take the square root of both sides, and wrong side of the equal sign there, but this gives me an X equals 12.8. But I don't believe I'm done yet because I see that ML is only a radius and I just found the diameter. So I'm gonna take this number and I'm gonna cut it in half. This gives me a 6.4 and no units, so this is my final answer. So now that we've done our do now, we can start transitioning into our notes. Now, I'm gonna make a note over here. Our objective is we're gonna be using formulas that involve arcs and angles formed by the intersecting chords, tangents, and secants. And that's gonna give us angle measurements and arc measurements. Our guiding question is what 3 formulas help us find arcs and angles in circles? And that's what we're gonna be talking about. So let's start by filling in the blanks. When chords, secants, and tangents intersect in a circle, on a circle, outside of a circle, so those are our 3 right there. There's in a circle, on the circle, and outside of the circle. Special relationships exist between the angle and arc measures formed. So start by identifying where that intersection is, because that intersection's location is going to be telling you which formula you need to use. So this is really all the key points you need to know, and we're going to be transitioning down into the examples now. So hold tight. If you miss anything, you can just rewind the video, which I wish you could do in real life. All right, so the first relationship we're going to be looking at is when we have that intersection inside a circle. So we see right here we have angle 1, and we see right here we have angle 2. Now, whenever we have an intersection inside the circle, that tells me that I'm going to need to add some things together. So we always remember, interior intersection, we add. So if we wanted to find this angle 1, so I'm looking for this angle right here, I would need to take 1/2 times the sum of arc AD, so that's this guy right here, plus the measure of arc BC. So that's the first one. We take the guy that's on the side of one and we add him to the guy that's on the other side. So you might notice with the measure of angle 2, we're just going to take AB, so that's the measure of arc AB, plus the measure of arc BC. So those are the two formulas, or rather, it's really the same formula, just with a different angle, that we can use to find the arcs inside of, say, this example right here. So I'm going to do this first one for us, and I just want you to follow along on your notes. So it's asking for the measure of AED. So AED is this guy right here. This will be X. So since I'm looking for the measure of an angle, I'm just going to leave X by itself because these formulas generate angles. So I'm going to start with an X equals. So X equals, and I'm going to start my formula. It starts with a 1/2. And then I'm going to take the measure of arc AD. Now if I look over here at angle 1, AD is on the same side as 1. So I need to take the arc that's on the same side as my angle. So that is a 45 plus, and then the arc that's on the other side, kind of the vertical angle relationship, we have a 109. Well, so far this is pretty simple. X is going to equal 1/2 times 154. So 1/2 times 154 is going to give me that the measure of angle AED is 77. So that's how we use the formula, specifically the formula of interior angles, or interior intersections. So these could either be chords, these could be secants. Ooh, a secant is a word we haven't covered a lot. Secants is whenever we have, say, a chord, but it's a line that just passes through the circle. So it's not like those guitar strings when we say we look up at the hole and we see the little guitar strings that go over. This probably looks weird on camera. But these would be secants because they travel through the circle and they're not bound by the circle. So just a little vocab addition. It's a weird noise. All right, so that's the interior intersections. I'm gonna leave this up here, and now we're gonna look down at when we have an intersection that is on the circle. So we see we have our intersection right here, and then we have two angles that fall on either side. So recall that these would be supplementary angles because they both lie on the same tangent line, and we know half of this tangent line would be 180 degrees. All right, so let's start with the formula for the measure of angle 1. This one gets a little bit simpler than the one when we have an intersection in the circle. So whenever the intersection is on the circle, we just need to cut some guys in half. So we take 1/2, and we're gonna multiply that by the measure of arc AB. So if you wanna find angle 1, you just take 1/2 of that guy. So that's the measure of angle arc AB. Well, guess what you're gonna do? For the measure of angle 2, I see that I have B, C, and that would be A. So I'm gonna take 1/2 times the measure of arc BCA. So this is a bit simpler in that all we gotta do is recognize the angle that's on the same side as the arc, and we just cut that corresponding arc in half. So when we come over to our example right here, it's asking us to find DEG. So DEG would be this very obtuse angle right there. And I see that on the same side, they just give me the angle, or rather the arc, that goes with this angle. So my job's pretty easy now. All I have to do, if I want to find the measure of angle DEG, is I just take 1/2 times the corresponding arc of 308. Well, this gets pretty simple. We just have 154 degrees as the measure of angle DEG. So far, so good. So these are the first two formulas. And I would say these two are the easier ones, because when we get to whenever we have an intersection that is outside of the circle, we're going to be doing some subtraction. So in that case, the order is going to matter of what we are subtracting from what. So here's example 1 and example 2. This is what you're going to be finding on your homework, so you should be able to do some of that now. And by the way, when I say homework, I mean if you do it, it's extra credit on your test, 2 points for every page that you do. Yeah, that's how I decided I'm going to do that. So I'm going to erase this now. We're going to look at our last example. So really the big key point in this lesson is just make sure that you commit these intersections to memory. All right, so let me move the paper down. And we have example 3. So the good news about whenever we have an intersection that's outside of the circle is we can only talk about one angle. And that one angle is just that guy right there. But his formula gets a little complicated because we have to do some subtraction. We still take 1/2. If you'll notice, every formula that we use has always started with 1/2, so don't forget that. 1/2 times the measure of arc CE. So if we look, that is the big arc, minus the measure of arc BD. So whenever we have an exterior intersection, we always take 1/2 times the difference of the big arc from the little arc. So let's apply this with this last example. I would actually like you to try it on your own. So if you want to pause the video right now and try it, you can do that. All right, so we're going to try this example together so you can check your work to see if it's the same as my work. So I know that I'm going to be looking for KLM, so this guy right there. So I'll make this X. So I have an X equals, start my formula with 1/2, and now I take the big arc. So if you want to think of this as big and this is small, that might be a good way to think of it. So we take our big arc, which is 140, minus the little arc of 66. All right, so very easy here. I'm just gonna subtract in the parentheses. Don't need to worry about distributing or anything like that. X equals 1/2, and in our parentheses we have 74. Well, 1/2 of 74 is not 30, yeah, 37. Aha, 37, so I know the measure of angle KLM is 37. All right, so that just about covers it. We got those 3 formulas. If you need to go back at any point in this video to maybe double check some things, you can do that. You can also use this video to help you do your exit ticket, which I'm gonna ask you to start right now. We are not gonna go over the exit ticket, so you will have to check with Mr. Agia, who I believe is probably gonna have the key. And if you check and you show him a correct solution, he will sign off on your tracker saying that you completed today's lesson. All right. So this is how we're going to be doing things while you're on your field lesson. I hope you're having a wonderful time and can't wait for you to be back. We got 3 more of these, so stay tuned.